This is Bob Capetta from the College of the Florida Keys, and this lesson is on the addition and subtraction of radicals. Note, in this lesson, assume all variables are positive. In reality, the square root of x squared is the absolute value of x. The cube root of x cubed is x, but we're not going to concern ourselves with that here. If all the variables are positive, the square root of x squared is the absolute value of x, which is the same as x. So please keep that in mind. I'll mention that when it comes. First question I have here is 5 root 3 plus 7 root 3. And you'll notice we could factor the root 3. If we factor root 3 out, I get 5 plus 7. Notice 5 times root 3 is 5 root 3 plus 7 times root 3 is 7 root 3. 5 plus 7 is 12. So the result is simply 12 times the square root of 3. Next up, I have 9 square root 2 plus root 5 minus 3 square root 2 plus 7 root 5. I want to reorganize this to get the root 2's together and the root 5's together. So I'm going to say 9 root 2 minus 3 root 2 plus root 5 plus 7 root 5. I want to factor the root 2 out of these two. So I get 9 minus 3 times root 2. Notice 9 root 2 minus 3 root 2. I have root 5 plus 7 root 5 here. So if I factor out the root 5 divided by root 5 is 1. 1 times root 5 is root 5. 7 times root 5 is 7 root 5. So I get 9 minus 3 root 2, which of course is 6 root 2. 1 plus 7 root 5, which is 8 root 5. We could also think of these as like terms, sort of. 9 root 2 minus 3 root 2 is 6 root 2. 1 root 5 plus 7 root 5 is 8 root 5. Next, I want to simplify 8 times the square root of 45 minus 2 times the square root of 5. I want to factor 45. 45 is 9 times 5, and 9 is 3 times 3. So 45, 9 times 5, 3 times 3 times 5. This is a square root. I need a pair to come out. Notice 3 times 3 is a pair. I'm going to circle that pair. I can also think of it as a square root of 9. The square root of 9 would just be 3. So I have 8 times 3 when that comes out. 8 times 3 times square root of 5, which is still left, minus 2 root 5. So 8 times 3, 24, times square root of 5, minus 2 times square root of 5. I can factor the root 5 out now, or think of it as like terms. Factoring out the root 5, I have 24 minus 2 all times the square root of 5, which will give me 22 root 5. All right, our next example, let's take a look at that. We have 6 times the cube root of x to the 5th plus 4 times the cube root of x to the 6th plus 2x times the cube root of x squared plus x squared. We want to simplify this. Now, I believe that we should factor these. So x to the 5th is x, 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 x. X to the 5th is x to the 6th, x, 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 etc. Now this is a cube root, this is a cube root, this is a cube root, so I look for triples. I circle a triple here, one of those will come out. I do not have a second triple. Here I'm going to circle a triple and another triple, both of them are going to come out. So what I'm going to have in the first piece is 6x cube root of x squared. What I'm going to have in the second piece is x, 4x squared, and the cube root goes away, nothing is left. Here, I don't have 3 of them to come out, so nothing changes here, and the last one stays x squared. So 6x cube root of x squared plus 4x squared is what these first two guys are going to be, 4xx of course, plus 2x cube root of x squared plus x squared. Putting them together, so I have 6x cube root of x squared plus 2x cube root of x squared. Then I have 4xx, 4x squared plus 1x squared. So you'll notice here I could factor the x times the cube root of x squared out of both of those and get 6 plus 2. Here I could factor out x squared to get 4 plus 1. Right? 4x squared plus 1x squared would be 5x squared. So factoring out the x times the cube root of x squared, we get 6 plus 2 for the first piece. Factoring out the x squared, 4 plus 1 for the second piece. So now I have 8x times the cube root of x squared plus 5x squared will be that result. Next, we are going to multiply square root of 3 times 7 root 2 plus root 6. So I need to multiply root 3 times 7 root 2 plus root 3 times root 6. So 7 root 2 times root 3 plus root 6 times root 3. Root 2 times root 3 is root 6. Root 6 times root 3 is root 18. So I have 7 times root 6 plus the square root of 18. Well, 6 is 2 times 3. 18 is 9 times 2, or 3 times 3 times 2. So we'll notice we have a pair here. We circle the pair there. So that comes out and that becomes 3 root 2. So my 7 times root 2 times 3 plus 3 root 2, 7 root 6 plus 3 root 2 will be my final answer. Next, I have another multiplication question. This time, again, I want to emphasize the fact that all variables are positive, just so we don't have to concern ourselves with square root of x squared stuff. But I need to distribute cube root of x squared times cube root of 5x minus cube root of x squared times cube root of 7. So cube root of 5x times cube root of x squared is cube root of 5x cubed, minus cube root of 7 times cube root of x squared is cube root of 7x squared. Well, I have 3 x's here, don't I? 5x times x squared would be 5xxx, minus 7x squared is xx. I don't have 3 of them to eliminate the radical for that part, but I do have 3 here. So I'm going to circle the 3 x's and recognize that cube root of x cubed is going to be x. That's going to come out and just give me x times the cube root of 5 minus, nothing simplifies here, cube root of 7x squared. And that's my solution. So we're going to continue our discussion on multiplication, although this time we're going to go to a binomial looking thing. 7 root 3 plus root 2 times 2 root 6 minus 5 root 2. We can distribute 7 root 3 times 2 root 6 minus 7 root 3 times 5 root 2 plus root 2 times 2 root 6 plus root 2 times negative 5 root 2. I'm going to use this to make sure I hit all of the products. So notice 7 root 3 plus root 2 on the bottom, 2 root 6 minus 5 root 2 on top. I'm going to multiply first. 7 root 3 times 2 root 6. 7 times 2 is 14. Root 6 times root 3 is root 18. So this cell first is 14 root 18. Next, we're going to multiply negative 5 root 2 times 7 root 3. 7 times negative 5 is negative 35. Root 3 times root 2 is root 6. So I get negative 35 root 6. Next up, I have root 2 times 2 root 6. So 2 root 6 root 2 would be 2 root 12. And then finally, I have negative 5 root 2 times root 2, which is negative 5 root 4. Now, many of these can be simplified. So let's go with our process. First off, 18 is 9 times 2, or 3 times 3 times 2. So that 3 comes out. 14 times 3 would be 42, with the 2 left. That'll give me 42 root 2. Nothing I can do with root 6. Root 6 is 2 times 3. Nothing is going to simplify. But obviously 4 is 2 times 2. Root 4 is 2. Negative 5 times 2 is negative 10. And then we have 2 root 12 down here. 12 is 4 times 3, or 2 times 2 times 3. The 2 comes out, multiplies that 2. 2 times that 2 out there will give me 4, with a root 3 still left in the radical. And we get 4 root 3. So we have to add all these together. Putting all these together, what do we have? 42 root 2 minus 35 root 6 plus 4 root 3 minus 10 is what that will equal when we multiply all those pieces together. Okay, I have another multiplication problem coming up. Root x plus root 5 times root y minus root 5. I again want to use the boxes to make sure I distribute properly. Root x times root y, root x times negative root 5, root 5 times root y, root 5 times negative root 5. So here's a way to visualize the distributive property. Starting first with root x times root y, it was the same as root xy. Nothing to simplify there. Next, root x times negative root 5 is negative root 5x. Here we have positive root 5 and positive root y. It'll be positive root 5y. And then we have root 5 times negative root 5. Root 5 times negative root 5 is negative root 25, which of course is negative 5. You could think of that as 5 times 5, pull it out, we get negative 5. So we're going to add all of these pieces together. Root xy minus 5 root x, check that, minus root 5x, plus root 5y minus 5 is my answer to that one. And you can see that this multiplication box is nice because you can sort of simplify it inside it and visualize all of the multiplication. Next, root x plus root y times root x minus root y. Here's root x plus root y down here, root x minus root y up there. Root x times root x squared, which of course is just x. Up here, root x times negative root y is negative root xy. Here, root y times root x positive root xy. And then root y times root y squared, which is just y, with a negative in front of it. So negative y is what we get here. So let's add all of these pieces together. X minus root xy plus root xy minus y. And you'll notice the root xy's will go away, leaving me a final answer of simply x minus y. And I believe I have one more problem for us to do. Here we have x plus the square root of 5 squared. So what does that mean? That means x plus the square root of 5 times x plus the square root of 5. So I'm multiplying two binomials. I want to use my multiplication box so that I can see the distribution. But again, x times x plus x times root 5 plus root 5 times x plus root 5 times root 5. X times x here is x squared. Root 5 times x is root 5x. Positive root 5 times x, another root 5x. And then root 5 times root 5 is root 25, which of course is just 5. So we've got to add all these together. X squared plus root 5x plus root 5x plus 5. But then what is that going to give me? A root 5x plus another root 5x will give me 2 root 5x. So my final answer to this question is x squared plus 2 root 5x plus 5. And that will complete this lesson.